This is the first part of your videos for week 8. This is going to consist of reviewing for the exam for Unit 2. We're going to start out just by talking about the exam and when and how you can take it. First of all, you can take the exam anytime during week 8 between Tuesday and Friday. It has to be completed by 4 p.m. on Friday. And just like with the last one, this is a paper and pencil exam, so it's not online. And it does have to be proctored. Because next week is midterms for a lot of people, the testing center in Scottsbluff is going to be extremely full. So to help out with that, I'm going to be proctoring this exam for anybody that can take it on Friday, March 8th between 8 and 11:30 a.m. So if you have that time available, you can come and take the test with me in room B2. If those times don't work for you, then you'll have to use the testing center in Scottsbluff, or if you're in another location, you'll have to take it at another campus or find another suitable proctoring arrangement. If you're going to use the testing center in Scottsbluff or use the staff at the Sydney or Alliance campuses, you have to make an appointment by next Tuesday, March 5th. Otherwise, you may not have the opportunity to take the exam. Now, this exam covers Chapter 3 and the first 4 sections of Chapter 4. You'll have 60 minutes to take it. You can have a calculator, but nothing else, so no phone, no iPad, nothing like that. Make sure to bring a pencil and your calculator, and also make sure that your calculator has good batteries. If it has started telling you that the batteries are low or that it needs charge, make sure that you take care of that before you come to take the exam. The next thing to talk about is things that you need to memorize for the exam. You already memorized a whole bunch of things for the Unit 1 exam, so I didn't put those on here again. You still need to know all of those things, but here's some additional things that you need to know for this exam. One of them is how to go from degrees to radians and vice versa. So the easiest thing that you can remember is that 360 degrees is equal to 2 pi radians. That also means that pi radians is going to equal 180 degrees. And this is actually what we normally use to convert from degrees to radians and vice versa. To do that, we talked about using the unit fractions. So you just use this fact and you use one of these 2 unit fractions, either pi radians over 180 degrees or 180 degrees over pi radians. This one is the one that you would use to convert from degrees to radians, because if you have an angle in degrees, you want the degrees to cancel, so you put the 180 degrees on the bottom. This is the one that you use to convert from radians to degrees, because if you have your angle measure in radians, then here the radians are on the bottom, so the radians will cancel and you'll end up with degrees on the top. The next thing you really should know for this exam is the domains and ranges of the 6 trig functions. For sine of x and cosine of x, both of those, the domains are negative infinity to infinity. For these, you can plug in any real number that you want. So you can say this in interval notation, or you can say all real numbers. Now the range for sine and cosine, if you think about what the graphs look like, they only go between +1 and -1. That's the range for both of these, from -1 to +1. Then we get to the other functions. For each of these 4 other functions, the domain has some values that have to be left out. For secant of x, since it's 1 over cosine, we have to leave out any numbers where cosine would equal 0. These are odd multiples of pi over 2. So the domain for this one is going to be all real numbers except for odd multiples of pi over 2. That's one way to write that. This one is going to be somewhat the same as that, only this time we're leaving out values where sine is 0. That would be any multiples of pi. For tangent, since it's sine over cosine, then we're going to be looking at the same domain as for secant, because we want to leave out anything where cosine is equal to 0. This is also odd multiples of pi over 2. And cotangent is cosine over sine. The domain is going to be the same as cosecant, because we want to leave out any values where sine is equal to 0. Then for the ranges of the functions, For secant and cosecant, since they're the reciprocals of sine and cosine, when you do the graphs, you sort of flip over the sine and cosine graphs. So these intervals for the ranges end up being exactly the opposite of what we have for sine and cosine. That means that we're going from negative infinity up to -1. We're skipping over this interval, and then we're starting again at 1 and going up to infinity. It's the same for cosecant. And then for tangent and cotangent, both of these, the ranges go all the way from negative infinity to. For these ones, there are no gaps in the graph as we go from the bottom to the top. We did a lot in this unit with graphing. So one thing you should really know is the basic shape and important features of the graphs of all 6 of these trig functions. For sine and cosine, you need to know the period, the amplitude, the 5 key points, and the basic shape of the graph. For both of these, the period is 2 pi and the amplitude is 1. These are actually the only 2 functions where we even talk about the amplitude. Now, the basic shapes of the graph, for sine, it starts at the origin and it goes 1 full cycle between 0 and 2 pi. And remember, we took that interval and divided it up into 4 equal parts. These are the x values for our 5 key points. And then for sine, it starts at the origin and goes up to the maximum, comes back to the x-axis, goes down to the minimum, and back to the x-axis. And that's what 1 full cycle looks like. So you need to know the x values of these 5 key points and just what direction it's going. Now for cosine, we've got the same period and the same amplitude. Our 5 key points have the same x values as they do for sine. So we're starting at x equals 0 and ending at x equals 2 pi to get a full period. But the cosine starts at a maximum point. Cosine starts here at the point 0, 1. Then it goes down to the x-axis, then down to the minimum, back to the x-axis, and back up to the maximum point. The biggest difference between sine and cosine is where they start and what direction they go. Sine starts at the origin and goes up. Cosine starts at a maximum point and goes down. The next 2 types of graphs we'll talk about are secant and cosecant graphs. These also both have a period of 2 pi. And we can't talk about the amplitude for these 2, but we can still look at what the multiplier is on the outside because that's going to affect the graph of sine or cosine x that we're going to use as a guide for these. For this one, our guide graph would be y equals cosine of x, since that's the reciprocal of secant. For this one, our guide graph is y equals sine of x. What we want to do for these 2 is graph the reciprocal function first. So do all the things that we would do to find the graphs for either sine or cosine with any kind of transformations that there are, and then use that to draw in our graph of secant or cosecant. So for this one, if we draw in cosine first, this is one reason it's so important to know what the cosine and sine graphs look like. Here's what our cosine graph would look like. And one thing that we do want to go ahead and mark in here is the maximum and minimum points, because those are also going to be points on the graphs of our secant or cosecant graph. Now that we have our cosine function graphed, we can put in our secant graph. When we have an x-intercept, that means for secant we're going to have a vertical asymptote there. We have one vertical asymptote here at negative pi over 2, another one at positive pi over 2, and a third one at 3 pi over 2. For these, if we include 3 vertical asymptotes, that will give us 1 full cycle of the graph, because that will give us 2 of those U-shaped branches. The important things to remember for secant are that it's the reciprocal of cosine, it has the same period of cosine, and you have to put in vertical asymptotes. You need to show 3 of those and then put in your branches, and it's going to meet the cosine graph at 2 points. For this one, we draw in our sine graph as a guide. And for sine, if we just draw 1 full cycle between 0 and 2 pi, then that's going to give us the 3 vertical asymptotes we need for cosecant. So we're going to have 1 vertical asymptote that's on the y-axis, one of them at pi, and one of them at 2 pi. Then we're doing the same thing we did with the secant graph, and that is we're putting one of these u's in each one of these places in between the vertical asymptotes. The things to remember here are that we want to put in 3 vertical asymptotes, and it's going to meet the sine graph at 2 points. For tangent and cotangent, one big difference is that the period for both of these is pi instead of 2 pi. So that makes a big difference when we're trying to graph these. Now, tangent is going to be increasing, so that means the graph is going to go up as we go from left to right. Now, these vertical asymptotes are going to be wherever cosine is equal to 0, since tangent is sine over cosine. Now, for these, we also had 5 key locations. So we had 2 vertical asymptotes, and we had our midpoint and our quarter point. On a basic tangent graph, this is where it's going to have an x-intercept, and the quarter and 3/4 points, that's where the function value is either going to be -1 or +1. For this, where cosine of x is equal to 0 would be at any odd multiple of pi over 2. So normally we draw the tangent graph just between -pi over 2 and pi over 2. Those are 2 locations of 2 vertical asymptotes. At its midpoint, it's going to go through the x-axis, so that's the point 0, 0. And then at the quarter and 3/4 points, it's going to be at either positive or -1. Since tangent is increasing, that means that this quarter point is at -1, the 3/4 point is at +1. Important things to remember here are where your asymptotes are located, -pi over 2 and pi over 2, and then just divide the interval between that up into 4 equal parts, so you've got your midpoint and your 2 quarter points. And that the tangent graph is going to be increasing, so it's going to go up as it goes from left to right. The graph of cotangent is decreasing, so it's going to go down as it goes from left to right. And cotangent is cosine over sine, so the vertical asymptotes happen where sine is equal to 0. That's going to be just multiples of pi. And for this one also, we have a midpoint, which is an x-intercept, and at the quarter and 3/4 points, y is either positive or -1.